Hey everybody, let's take a little bit of time and talk about how the physical constants sheet for experiment 3 is slightly different than the ones that you've done previous. Now, it's slightly different in that you're going to have to fill out all the information as opposed to just some of the information. Previously, you'd have to fill out this, and then the amount used in either grams or milliliters, and then this, and this. Okay, well, there's really not much else to fill out. So let me just say that for this lab, you're going to have to fill out this column, in order for it to be complete. And actually, these columns are maybe the most important in doing the lab. So let's make sure that we know how to fill this out. And anything that we do to calculate these things will go in the pre-calculations section. So you're going to have a page that happens probably before this, okay, or just afterwards, which is going to be pre-calculations that you're going to put in here. Now this lab builds into some of the future labs because it gives you the data already for some of this stuff. It tells you how many milliliters and moles of cyclohexene, water, and sulfuric acid we need. But that doesn't mean that we still don't need to do a calculation, because if we look, okay, let me just fill this out a little bit. Okay, this is 20 milliliters. Make sure you put the right unit, and it's 0.2 moles, 0.20 moles, but we still have to fill in the theory and the used. Okay? In theory, when we have the reaction here, in theory, the reaction has a 1:1:1 ratio. That's the theory behind this. So when you go fill that out here, you should put 1, 1, 1 in there. But what we actually have, and this is this column right here, the used column, okay, what we actually have is, let's see, 0.2 moles, 0.44 moles, and 0.3 moles. Let's see, so we're going to go back here to our calculation. So it's 0.2 moles of this guy and 0.44 moles of water. Now, that ratio, what we're going to do is we're going to pick the smallest of those, and there's actually 0.3 moles of H2SO4. We're going to pick the smallest of each of these. So the smallest here is cyclohexene, and that's going to be 0.2, and we're going to divide each of them by the smallest. And so that gives this as a ratio of 1, and then this is 2.2, and this is 1.5. And so that calculation is something that I want to see on your pre-calculations page, because that shows you what the excess reactant is. Not only do you have to put it there, but you also, if you look at the very bottom, and a lot of people miss this, okay, you want to calculate the limiting reagent. Which one is present in the least amount? Which, if we go back here, let's see, present in the least amount looks like that one. Stoichiometrically, it's a 1:1 ratio. Okay, so that's still this guy. So when we go back here, okay, the limiting reactant, or the limiting reagent, is cyclohexene. And then what is the theoretical yield? Well, we have to look again. Okay, back here, if you need to calculate it, that's cool. Okay, remember, 0.2 moles of spell that right, hexene. And then we want to convert that. I use the X line. And now, based on the stoichiometry, for every 1 mole of cyclohexene we have, there's 1 mole of cyclohexanol. And so that's a 1-to-1 ratio, so that means we're going to get 0.2 moles of that. So back here, we're going to get 0.2 moles of that. And then this is the part that really screws around with people, is converting that to grams. So let's go here and show you what you need to do. So now we know that there's 0.2 moles of cyclohexanol. Now we want to convert that from moles to grams. And I always use this X line where moles will cancel. The thing that we want to cancel has to be on opposite sides of each other. Okay, one on the top, one on the bottom. Okay, and then for every 1 mole, we look up the molar mass of cyclohexanol. So that's 84, so that's 100 grams per mole. So we should expect 20 grams of this guy. Okay. Now you're going to carry this out a little more formally, but that's the type of calculations that you're going to do. Okay. And so then that's going to go down here on this line. So that goes over those 3 lines here, and it goes over what to put in for this, this, and this column. Okay. In future labs, you may actually have to convert to moles and use that, use what you know to convert to moles. So that's what makes the physical constants and pre-calculation sheet different, or in addition to the regular pre-lab. I hope that helps. Have a great day.